Hello, my name is Ken Ground, and I want to give you a brief introduction on this video, which covers the use of the monthly star charts on my website, whatsoutTonight.com. Immediately following this short introduction, I will list all of the various parts of this video. The very first part gives you an overview on how to use the monthly star charts, to find the stars, the constellations, and the planets in the night sky. But there's many parts to this video. Each of them is titled, and so you can either scroll or fast forward to those depending upon your needs. So enjoy the night sky. I hope you get out there and at least learn some of the brighter stars and constellations. Get a chance to look at the planets and some of the other objects through a telescope. The heavenly bodies are beautiful, and if you get to the place where I am, they can absolutely become your friends. Okay, take care, have fun, bye. Hi, my name is Ken Ground, and I'm going to give you a short introduction on how to use the monthly star charts on my site, whatsoutTonight.com. Before I get into explaining the use of the star charts, I'd just like to say that if you've never gone out and found constellations before, if you know of a friend or an acquaintance who has that skill, I would highly recommend seeking them out, because in as little as 15 minutes they can get you going for a lifetime. So that would be an easy way to jumpstart the learning process. If you don't have that luxury, I hope that the information that I give you will be useful for going out and starting to identify the stars and the constellations. There may be a little bit of a learning curve, but I guarantee you everyone can do this, and it's a worthwhile endeavor, because once you start recognizing them, it will be fun, rewarding, and eventually, or maybe very soon, the stars and the constellations can become your friends. Okay, the monthly star charts. There's a reason why they're in a circle. The circumference of the circle represents your horizon. Okay, so that means that all the stars and the Milky Way band, that gray band is the Milky Way band, all the stars and the Milky Way band will be in your night sky. Now, since the circumference represents your horizon, and you may have noticed I drew some like mountains and trees there to indicate that that's what it is. But since the circumference represents the horizon, that means the middle of the chart will be those stars that are directly over your head. Now, when you go out and want to use this star chart, especially for the first time, I recommend facing one of the 4 cardinal points. And that you may be sort of shoved or pushed into one, depending upon what part of your sky is light polluted or not light polluted, or blocked by buildings or trees or whatever. I have, for example, where I live, my northern sky has more light pollution, because that's the direction towards the city. Where my southern sky is, it's very dark. It's great actually. So those are some of the things that might push us in standing in one direction or another. Now, along the circumference, you can read I have south horizon, east horizon. If you turn it upside down, north horizon, and finally west horizon. So depending upon what cardinal point you are standing at and facing, you need to turn this chart so that the equivalent cardinal direction is down. So in this case, I'll turn it to the east horizon, and in essence, the star chart is sideways. Now, after you do that, is I want to just point out the stars that you will be able to see if you casually move your head around. So here again, I'm at the east horizon, and you'll be able to, let me get up here, you'll be able to see the oval that I am making with my finger. This oval, which goes basically to the top of the sky, or the zenith. The zenith is the top of the sky. This oval represents the stars and constellations that you will be able to see if you casually stand in one direction and move your head all around. So in other words, if I just, as I'm doing now, if I just sort of rotate my head around, and that will give you the oval of stars around any of the cardinal points. Okay. Now, I have down next to the south horizon, I have the magnitudes of the stars. Just real quick, bigger positive numbers mean dimmer stars. Negative numbers mean brighter stars. The planets, especially Venus and Jupiter, they are always negative numbers. So negative, Venus has like a magnitude of about -4. That is much brighter than Jupiter, which has a magnitude of -2. Now, in relationship to that, most stars have magnitudes of about 1 to, let's say, 5.5, those that you can see with your eyes. Sirius, the brightest star in the sky, is about -1.4. But the way magnitudes or brightness of stars are indicated is by their size. The bigger the star, the brighter that it will be in the night sky. Okay? So the bigger the star, the brighter it will be. The smaller the star, the fainter that it will be. So your job is to go out and to start matching up the big stars on the chart, that is the brighter stars on the chart, with the brighter stars in the sky. And that can take a little bit. If you haven't, when I say a little bit, it can take a little bit to orientate yourself to that correspondence. But it's not difficult, and like I says, everyone can do it. Now, in relationship to that, the constellations themselves, on average, are much bigger than what people will normally think. Orion and the Big Dipper, they easily basically span the distance of a hand stretched out, and that's about the size of Orion and the Big Dipper. There are smaller constellations. There are some larger constellations that stretch across the sky. But again, most constellations are bigger than what people think. And in relationship to our talking about constellations, what about the lines? The lines that I have drawn on this chart pretty much represent the patterns that I personally use, and also which most everyone else use. If I had drawn all the lines that, for the most part, outline the mythological figures, there would be too many. It would get too confusing. The lines on this chart follow the brightest stars and the pattern of stars that most people would actually recognize. Now, one of the reasons why I have monthly charts is that the planets move, and so on each chart is indicated the naked eye planets and their position at that time. The magnitude of the planets are indicated on this bottom little bottom table here. So that will give you an idea about how they will compare to the stars, that are in the night sky. That is, compare at least brightness wise. Again, the Milky Way band. The Milky Way band is best seen in a dark sky, and the Milky Way band is actually brighter than what most people expect, as long as you're in a dark sky. In fact, almost everyone just becomes sort of fixated looking at the Milky Way when they see it bright for the very first time. So that's a general overview of the chart. I hope you go out and enjoy the night sky for all that it has to offer. because it's a magnificent view. Okay, you take care. Good luck. Have fun. Bye. Hello. In this part, I want to talk a little bit about why I have monthly star charts. There are two main reasons. The biggest reason is that the set of stars and constellations that we see from month to month changes. Okay, so it only changes a little bit maybe each month, but the sky is still different. In 3 months' time, there's a big difference. In 6 months' time, it's a totally new set of stars. There's no overlap. So that's the first reason, and I'm going to talk about that a little bit more. The second reason is because the planets. All of the planets change their position in the night sky from month to month, and so the monthly charts plot where they are. Depending upon the planet, Venus can move a lot, and on some of the star charts, I will indicate where Venus is at the beginning of the month, and then like at the end of the month. Saturn and Jupiter generally move a lot slower, but they still make progress across the fixed patterns of the constellations. So I like to indicate where they are, so that you can pick them out in relationship to the fixed stars. Okay, let's talk about the reason why the stars change from month to month. In essence, the stars and constellations are fixed. Okay, that's what I will say is the rock. They are fixed. They do not move. The stars, all the stars that we see are extremely far away in comparison to our solar system. The stars actually do move, like the sun is actually traveling through space, but because the stars are so far away, it just looks like they are basically a permanent, unchanging backdrop. And one way to think about the stars themselves, the constellations, is being on the inside of a sphere or a ball. And so because that's all, when you look anywhere on Earth and you sort of add it all up, it looks like a sphere that the stars themselves are painted on a canvas, which is spherical. And I have a drawing here. But there's one thing that moves. The stars are fixed, but the Earth's not. The Earth revolves around the sun. As we know, it takes one year for that to happen. And the night side of the Earth, which if you sort of look at it from this perspective of the orbit, we'll call it the backside. The night side / backside is absolutely pointing in different directions throughout the year. So since the stars are absolutely stationary, but the Earth is not, and the Earth's night side or backside is facing in different directions throughout the year. That's why the constellations change from month to month. Okay. Now, in relationship to that, the stars also move or change throughout the night. My monthly constellation charts, they are basically tuned to show you the stars that will appear in the sky about an hour and a half after sunset. And the reason I chose an hour and a half after sunset, it's usually pretty dark to see all of the stars fairly well. And also, that's about the time that most people actually go out and look up. But if you went out and looked up later, let's say at midnight, the stars on the chart, there will be a lot of stars on the chart that are not in the night sky. You could actually use one of the other charts to give you insight into what's up there. But here's another drawing I just wanted to show you in what I was trying to explain visually what I was talking about. So we have the Earth, we have the night side, and the arrows. The arrows would be, you know, your movement, the direction that you would be looking throughout the night. The Earth obviously rotates on its axes. That gives us our day and night. So throughout the night, you know, we will be looking in different directions on that canopy of stars, you know, that does not move. Okay, so those are the main reasons why I have the monthly charts and why the stars change from month to month. So go out and try to find those constellations. If you can find them, that's great. And I'm hoping what will happen to you, as has happened to me, is that, you know, over the years, as I've gotten to know the sky better and better, I'll step out. At times, I'll recognize, you know, some of my favorite constellations, and they become friends. They become friends that are just that are really a part of my life. Okay, thanks a lot. Have fun. Bye. In this part, I want to talk a little bit more about the Milky Way band and what it represents. The Milky Way band on the charts, it's always indicated by a gray irregular band, generally that sort of arcs through the night sky. But what is this thing? And I'll get into that in a minute here. But the thing about the Milky Way band, even if you didn't know what it is exactly, it's beautiful. You know, it's absolutely beautiful to behold, and everyone enjoys looking at it and running their eyes along its length in the night sky. Now, the only problem with that is that you have to be in a pretty dark sky to see the Milky Way band. The cities you can't see it at all. Outskirts of cities, you might be able to maybe see it a little bit, but to be honest with you, not really. Its true glory shines in a darker country sky. The thing about the Milky Way band that surprises most people is that it's much brighter than what you would expect. When you're in a nice dark sky and you look up and you start seeing what almost looks like clouds, but you know, sort of stretches in a linear way. That's the band, and people who are unsure of what it is, they say to themselves, "Is that the Milky Way?" and it is. It's exciting. It's beautiful. During the summer months, especially maybe the latter part of the summer and early fall, that's when the thickest part, the brightest part of the Milky Way is visible. And in North America, that part will be a little bit above the southern horizon. That part is actually between the constellations Scorpius and Sagittarius. Okay, what is the Milky Way band? What does it actually represent? And the Milky Way band represents the bulk of the stars in our galaxy. And before I go further, let me just back up a little bit. If you could hold, put this down, if you could hold the whole universe in your hand, it would be basically the shape of a sphere, a ball, and you would see a couple 100 billion fuzzy specks. Each one of those fuzzy specks would be a galaxy. Okay, so there's a couple 100 billion galaxies in our universe. Galaxies are the home of stars. In essence, there are no stars between galaxies. So galaxies represent a group of stars. And a galaxy can have anywhere from, let's say, a couple billion to maybe up to 1 trillion stars. So our sun is one star in one galaxy in the universe. Okay, so our sun is one star in one galaxy in the universe. And we have named our galaxy the Milky Way galaxy. And the reason why, and I think you probably sort of caught on already, the reason why we call our galaxy the Milky Way galaxy is because the Milky Way band has always been, in most cultures, called Milky, and maybe a little bit more recently, called the Milky Way band. That Milky Way band represents the bulk of the stars in our galaxy, which of course, as I've just said, is the Milky Way galaxy. I have a picture here, I think you can see, is this one right here, and I think you can see the arms and things. This is a picture of sort of what our galaxy looks like. There's no way we can go out and take a picture of our galaxy, but this is one that approximates the Milky Way galaxy. Although there's various colors in here, for the most part, the galaxies aren't quite this colorful. But everything that you see in here, all the what's called arms radiating from a nucleus or core, this is the light from the billions of galaxies. And this type of galaxy, which is again similar to our Milky Way galaxy, is called a spiral galaxy. And again, that's from having a core with what we call arms, radiating outward from it. So our Milky Way galaxy, in essence, looks like a frisbee. That's the way I often like to describe it. And the frisbee is relatively thin, but it has that big circular disc. And in this diagram that I have right here is that we have the core. The circumference of the circle represents the basically, I'll say, the outside of the frisbee disc, and our sun is located approximately 2/3 of the way out from the core, nucleus, or center. Now, if I raise this a little bit, our galaxy is very thin. Yes, the nucleus does bulge a little bit, and that nucleus represents that bright area between the constellations Sagittarius and Scorpius. But you notice that the thinness of the galaxy, if it's viewed from the side, and where the sun is, it's basically just a straight line, and that straight line represents the band that we see in the night sky that we call the Milky Way band. Okay. Now, probably I think one of the clearest ways to understand why or how our galaxy could appear as a band is to basically use a hula hoop, and it just so happens I have one. So here's a hula hoop. This one has some beads in it, so it makes a little noise as I move this. Contrary to popular belief, no, I do not use this hula hoop on a regular basis. Maybe once every couple of years, just to show off to grandkids and things. Okay, but as you can see, I have my head in pretty much in the middle of the hula hoop, and what do I see? What do you see? We see a band, and this band, in essence, would represent the bulk of the stars, in our Milky Way galaxy. The bulk of the stars in the disk, and this is why, in essence, our galaxy appears as a band in the night sky. Okay. Okay, thanks, and I hope you visit some of the other parts to learn a little bit more about different aspects of the star chart, and also about getting some observing tips. Thanks. Bye. Hello. I want to talk a little bit about the moon in this part. The moon has more lore about it than any other object in the night sky, and for obvious reasons. One, it has phases. It goes through phases. A crescent to half to full, and then to another half, called last quarter, and then it disappears for a little bit before it becomes a crescent again. I'm not going to talk about why we have the phases, except to say that it's a perspective view from Earth to the moon. So it's a perspective view of our line of sight. But one thing I do want to say is that the moon, half of the moon is always in daylight, half of the moon always has a night side. So there's always half of the moon has a day side, and the other half always has a night side. And so the phases are nothing more than seeing part of the day side and part of the night side. Now the brightness of the moon is a little bit of a problem for those of us who want to observe the deep sky objects. You know, that is the nebula, the galaxies, and the clusters of stars. The moon, a bright moon, washes out the night sky. It prevents us from seeing the fainter objects, and to be honest with you, if it's a full moon, the full moon pretty much washes out the night sky, and it's not real easy to see a lot of stars and constellation patterns at that time. But what about observing the moon? I tell you, the moon is a fantastic object to observe, but the best time to observe is pretty much when it's from a crescent to about the first quarter moon, and maybe a little bit beyond that. And around full moon, the moon is washed out. It's there's no contrast or anything between anything. There's no shadows, and it's those shadows that can give us the incredible views of the moon's surface. Now, what I said is that the best time to observe the moon is when it's out of phase, and especially I'll say more of the crescent phases. When it's crescent, as we all notice, there's the dark side, the dark part, and then there's the lighted side, and there's that line that separates. That line is called the terminator, and the terminator again is the line that separates really the night side from the day side. But right along that terminator, the shadows are their most pronounced for craters and mountains. And because the shadows are more pronounced, the contrast of everything on the surface is at its best. In other words, this is the time, it's the time and the place along that line to see detail. When I observe the moon, if I'm showing it to the public, I generally just start out at about maybe 50 to 100 times. But if you have a nice, steady, and clear night, and if your telescope can handle magnifications of, let's say, 200 to maybe up to 300, that's what you want to use. When you have a nice, steady night, when the atmosphere is not turbulent, that is when the telescope is at a high magnification, the clarity, the surface detail on the moon will be excellent. Is that it at around 300 magnification along that terminator, it looks like you're actually flying over the surface. The detail is absolutely magnificent. I think in some ways we tend to maybe just overlook the moon because there's so much to do in the night sky. But some of my best memories, and there will be more of those to come, is when that terminator is on the moon. Basically, just pointing my telescope to it and just running it along that line, that terminator line at high magnification, especially when the atmosphere is steady. It's absolutely magnificent. It's the closest to getting to feeling like you're basically on the moon. So enjoy it, and again, have fun with the night sky, with the moon, with the planets, with the deep sky objects. Maybe as just as a last little recommendation. If finding things in the night sky, or if you don't have a telescope, and there's just about in every community there are events. There's astronomy clubs, and sometimes if there's planetariums or there's a nearby observatory, they often have events that are open to the public where there's telescopes and things like that. So let them do the work. Let them do the work. There's usually big telescopes, bigger ones that you and I maybe don't have. Let them do the work, and you can just walk around and have fun, showing what they have, and seeing the night sky. Okay, take care. Again, have fun. Bye. Okay, in this part, I want to talk about the naked eye planets. Now, I'm calling the naked eye planets Venus, Mars, Jupiter, and Saturn. Oh, that's good. I got them in order. No, I need the order. Okay. One thing about actually, there's a lot of things about the planets, but let's maybe first start out with the chart. On the chart, there is an arc, called the ecliptic. Okay, and on this one, it's right here, and then that's going to move a little bit from month to month. But you will find all of the planets, not just the naked eye planets, either on or very close to the ecliptic. They never vary far from the ecliptic. The ecliptic is the actual ecliptic. The actual line is the path that the sun follows in the sky. And the sun doesn't really create a path in the sky. It's actually the Earth revolving over a year's time around the sun that creates what looks like the sun moving through the set pattern of the constellations. But and everyone knows, you actually all know the ecliptic. The ecliptic passes through what? The constellations of the zodiac. So that's where the constellations of the zodiac come from, because the sun's path in the night sky passes through those 12 constellations. But one of the reasons why the planets stay on that path, well, actually it's the main reason, not one, is that all of the planets, including Earth now, they orbit in the same plane. So basically, the planets orbit all on the same plane. When I say the same, some of their orbits are tilted a little bit, and that's what maybe slightly removes them a little bit from the exact ecliptic path. But yeah, so all the planets all the time can be found either on or very near the ecliptic in the sky. Again, that ecliptic goes through the 12 constellations of the zodiac, which everyone is familiar with. The observing the planets. The planets are best observed with a telescope from magnifications from about, I'll say, 50 up to maybe about 250 to 300 times. The higher magnifications, that will be determined more by the steadiness, the turbulence in the night sky. The night sky sometimes can get turbulent. Views of the planets on a turbulent night through a telescope, it's not great. In fact, they look like they're bubbling. But at certain parts in the night, sometimes that turbulence settles down, and some nights there's almost no turbulence at all. But again, the planets are best observed to a telescope. Now, when I say that, it is possible to see the 4 what we call Galilean moons of Jupiter through binoculars. Okay. About one interesting thing about the planets and observing them. Sometimes I always forget to say this is that they can be observed in light polluted conditions. So if you can see the planets, in your city, you can observe them in a telescope in the city, and the light pollution will not degrade the image quality of the planets, as long as the atmosphere is steady. So that's sort of a bonus with the planets. The planets, Venus. Venus is often referred to as the morning or as the morning star or the evening star because it orbits inside its Earth orbit. It hugs or stays pretty close to the sun. But Venus is always the brightest object in the sky, well, other than the moon and the sun. And it often looks like a beacon. And if it's low, you might actually think it's a light on a light pole. It can be that bright. But I often get inquiries about what is that bright star in the in the west or the east sky, and it's almost always Venus. It's very bright in comparison to any of the other planets, and especially to any of the of the stars. And again, Venus will only be up maybe a few hours after the sun sets, because then it will set, or it may rise a few hours before the sun. And again, it's very, very bright, and it will always be very close to the sun. It's always tied to it. The Jupiter is a very bright planet also. It's not quite as bright as Venus, but Jupiter is brighter than any star. Sirius is the brightest star in the whole night sky. Jupiter is much brighter than Sirius. Now, Jupiter has been called the king of the planets, and as we know that's tied to mythology. Jupiter, Zeus, the king of the gods. The reason for that is that because you might say, well, Venus is much brighter. Why isn't that the king of the planets? The reason is because Jupiter can stay up all night. It can literally be up from dawn to dusk, and it is very bright. Again, much brighter than Sirius. And so its ability, and this is only because it orbits outside of us, but it's that ability to stay up all night and to be very bright. That's why it has been it was called or dubbed the king of the planets. Jupiter has 4 moons. They're all right around the same size as our moon. They are easily visible in a telescope with low magnification of 50 or even less. Those moons move very rapidly around Jupiter, and you can see some movement of the moons that are closest to the Jupiter's disk in as little as 5 to 15 minutes. Sometimes you don't see all 4 because some might be in the back, some might actually be in the front. What is in what we call actually a transit. Jupiter also has 2 parallel bands. One is in the northern hemisphere, one is in the south, and those are also very visible in telescopes. Maybe you might need 100, 150, a couple hundred to see the bands well, and on a good night you'll be able to even see more detail in and around those bands. Saturn is the planet that it just thrills everyone when they first see it. Those rings are magnificent. The greater the magnification, up to 200 to 300 times, you get to see the planet bigger and bigger. You'll see more details within the rings, and the Saturn is absolutely neat to see its ring system for the first time. One of the comments I always get is some people think that I have put that there's an image of a slide, an old slide from film, in front of the telescope, and that's what they're seeing, and that they're not actually seeing the planet. But no. When you look through a telescope and you see in Saturn, it's a joy. And it's not a slide, and but you can have fun with it. Say it's a slide if you see it for the first time. It makes us smile. When we're showing it to you. Okay, have fun with the planets. Again, you can observe these in light polluted skies in cities as long as you can find them. So the planets are great. Okay, take care. Thanks. Bye. Mars, the red planet, the god of war. So Mars is the one planet that a lot of us like to observe, and that has piqued our curiosity for hundreds of years. It's, you can go all the way back to Kepler, right around 1600. Kepler studied Mars, and that helped him develop one of his laws for planetary motion. But he for some reason, although he had no evidence, believed that Mars might actually be inhabited. And we go forward to right around the beginning of the 1900s. There was Lowell. In fact, Percival Lowell had an observatory in the Flagstaff, Arizona area, and he believed that he saw canals on its surface, which would indicate to him that there was intelligent life. But all that has changed. We now know that Mars pretty much looks like a desert, but without plantation. However, our interest is still piqued considerably about Mars, mainly because it may harbor life. That life might just be microbial, and it might be relatively deep in its soil. But most of us think that it is there. Mars is the most explored planet in our solar system. I think, as everyone knows, there have been a few rovers that we have landed on Mars to explore its surface, and there are numerous spacecraft that orbit Mars to look down, to take pictures and monitor any changes that occur over time. We do know that Mars's poles basically are a combination, and I say poles, that is the North and South Pole. It's a combination of water ice and dry ice. Dry ice is frozen carbon dioxide. And speaking of carbon dioxide, Mars's atmosphere, it's almost basically it's 100% carbon dioxide, but it's very thin. Carbon dioxide is not poisonous, but we cannot breathe it to survive. Okay, Mars is an interesting planet to observe. There's a lot that can be seen even with a small telescope. I normally observe Mars with telescopes from about 4 inches in diameter to 6 inches. You can see a lot of detail on Mars with a telescope as small as 4 inches. But and I use "but" because there's a caveat, and there's a reason why I have this separate part here on Mars and did not include it in the other part, because Mars requires a little bit more attention to detail when it does come around, availing itself to be observed in I'll say in detail. But let's just talk about Mars and maybe its sort of orbital qualities and when we can observe it, and then I'll talk a little bit more about some of the things that can be seen. Mars is the next planet out from Earth, and its orbit is approximately it takes 2 years for it to complete an orbit. And as a sidelight, Mars's day, that it's its rotation, it's just a little bit over 24 hours. So it has some similarities to Earth that way. But physically, Mars is only 1/2 the size of Earth. It's about 4,000 miles in diameter. Now, like I said, everyone likes to. When I say everyone, when you get into this, basically you wanna see Mars. You want to see some of its features, but you can only do that about every 26 months. Okay, so every 26 months, the Earth and Mars get close together in their orbit, and that allows anyone with a telescope to study Mars, because it will appear its largest at that time, and at what I'll say here, a reasonable size where you can see detail. Mars at its closest ranges anywhere from about 36 million miles to a little bit over 60 million miles. So even at its closest, its size can be twice as large as when it is at its closest. So now when it's not at its closest, when it's not anywhere between, let's say, 36 or 40 million miles and 60 million miles, it's fairly far away, and it just becomes too small to really see any detail, any surface features. So the greatest distance that Mars can get from the Earth is about 250 million miles. And so that means from opposition is that closest approach. From opposition, or its closest approach, to the farthest it can get, there's a factor of 8. So Mars can literally, basically shrink down to almost nothing when it's not at opposition, again, which is its closest approach. Now, one of the neat things too about opposition is Mars' brightness greatly increases to right around magnitude -2. Now again, negative magnitudes means that objects in the sky are brighter. The moon's about -12, the sun about -27. So Jupiter consistently shines at -4. -4. That's Venus. Jupiter consistently shines at -2, and so every 26 months, Mars gets up to the brightness of Jupiter, and when Mars is at -2, yeah, it's a nice beacon in the night sky. Outside of that I'll say short period of time, which is really just a couple of months when it's very close to Earth, Mars' magnitude, or its brightness, fades to what I will call a relatively inconspicuous +2. And when it's +2, it's not that easy to notice in the night sky. Okay, let me just go over some of the dates when Mars will be at opposition. And okay, some of the upcoming dates. In May of 2016, Mars will be at opposition. In July of 2018, Mars will be at opposition. In October 2020, Mars will be at opposition. December of 2022, and the last one I'll give you is January of 2025. So those are upcoming years where when Mars will be close, it will be bright in the sky, and it will be those will be the most favorable times to observe surface detail. Now, what can you see on Mars, and how do you get there? You need to have, a 4-inch telescope is adequate. The larger the telescope is, that can help you out a little bit, but not significantly. About the telescope that will give you the most detail is about an 8-inch. When I say the most, that is if you start increasing the diameter of the telescope, you're not going to really see much past what an 8-inch can give you. But magnifications, for this one you need high magnifications ideally, and nice steady nights where the air turbulence is low. That we can't control, so that's one of the things we have to just cross our fingers and hope for. But magnifications from about 50 and now about 100 to maybe 350, and you most likely to see the detail that that will be most appreciative would probably be right around 200 to 350. When Mars is closest, you want to observe it ideally maybe around midnight, and because right around midnight it's going to be the highest it will be in the sky. The higher it is in the sky, in your night sky, the better the view is normally, because that takes it out of any turbulence, which can be low in the sky. And speaking of turbulence, and something called moments of clarity, observing Mars some nights and some parts of the night, different times of the night, may just be better than other times. So you want to observe Mars as frequently as you can to basically see as much as you as is possible. But again, there's been nights when I've observed Mars and the turbulence in the night sky is so bad you cannot really see any surface features. There's been other nights when I've observed where there's been what's called moments of clarity, which might last a couple of seconds, and then you can see the surface features pretty clearly. And again, this is even in a 4-inch telescope, but the magnification is pumped up a fair amount. Moments of clarity, and that's normally what we have to work at, because the atmosphere is always moving. It can often be very turbulent. Moments of clarity are like maybe a split second or maybe up to a second or so, sometimes a couple of seconds, where the atmosphere calms down, and in essence it becomes, basically very transparent. There's no turbulence or what I like to call bubbling, and you can see the surface features very distinct. Often often the glimpses you get of the surface features may just be through little moments of clarity that pop in and out as you're looking at the planet. What can you see? What surface features you can see? You can always see at least one of the poles. Okay, you can almost always see coloration on a difference in coloration on its surface. I say always because there are some sides of Mars that don't have a lot of surface coloration, where there's other sides that have what I will call just really interesting, intriguing surface colorations, and I'll show you some pictures of that in a second. You can also see some clouds. Usually the clouds are often around the rims, and occasionally you can see clouds on the surface itself, generally over some of the features. I'm going to say on rare occasions, and this hasn't happened in a while, Mars can kick up sandstorms, and those sandstorms can obliterate an area of Mars, like a considerable area. And in the worst case scenario, Mars is the whole surface, the whole planet can be completely obliterated by sandstorms. Those haven't happened in a while, and unfortunately they whitewash the surface, and you can't see anything. Now I mentioned some pictures of Mars here, and you can obviously look on the internet and get some pretty spectacular images from the Hubble spacecraft and stuff. But these bottom ones, you can in fact, what you're probably seeing on the camera is pretty close to what you might actually see through the telescope. A little blurry, not perfectly sharp, but you still can get some distinct colorations. And like in this one right here, you can see the pole. That's very much what it will look like. This big appendage right here is Syrtis Major. The differences in the color on the surface, for the most part, it's just a difference in the rock size between the rock and the sand on the planet. So this is basically what Mars looks like through a telescope. Now, Mars is often very disappointing, and this is at opposition. It's often very disappointing to first-time observers, that is, people who haven't maybe observed a lot, because they expect to see it, like one of the Hubble Space Telescope pictures, and that's not going to happen. Plus, first-time observers don't really know what to expect and what to look for. They're just hoping to see something spectacular, like maybe a Martian jumping out of off the surface, or something like that. But if you become familiar with the basic surface colorations, identify, and of course about the poles, and some of the other features. So if you become familiar with that, and you look and you observe and you're observing through the telescope, you will slowly but surely be able to see those, see and recognize those colorations, and of course the poles, either of the pole, because you'll just be able to see one, almost always stands out. But if you're relatively new to it, I recommend that you start observing about 1 month before opposition to 1 month after. And if you observe about the same time each night, over a period of about 40 days, you will in essence see one complete rotation of the planet, and hence you will see all of its surface colorations. So you can see a lot more on Mars than what you might think, especially after maybe the very first time you look at it. You can see a lot more detail, and it really is. I look forward to when Mars comes around, to basically look at the colorations and some of the other features. It's a treat. It's a treat that everyone enjoys. So the next time Mars comes around, I hope you get out and take a look at it, enjoy it for all that it has to offers. Thanks a lot, and good luck. Bye. In this part, I want to talk about objects in the night sky. And when I say objects in the night sky, well, that could literally be anything. But in particular, about clusters of stars, nebulae, and galaxies. These things are often referred to as DSOs. That is DSOs, deep sky objects. So if you're around people, amateurs who spend time with astronomy, you will hear the acronym DSO tossed around quite a bit. So DSOs, deep sky objects. What that actually means is it's a set of objects other than stars. A set of objects other than stars, and it connotes objects that are at a distance. So things like, again, clusters of stars, nebulae, and galaxies fall into the list of deep sky objects. Before I describe some of the deep sky objects, I should mention that there is one famous list or catalog of deep sky objects, and that's called the Messier catalog. Charles Messier was an observational astronomer roughly in the middle of the 1700s. He was from France, but he resided and did all of his work in Paris. He was the very first astronomer to compile a list of deep sky objects. And because he was the very first astronomer to do that, he pretty much picked off the biggest and the brightest. And his list, there's basically 110 objects on the list, and almost all of those objects you have heard at least of some of them. So let's talk about some of the deep sky objects. I said clusters of stars. Stars are born in clusters out of a nebula cloud. So I'm actually combining a few things here, but stars are born in clusters out of a nebula cloud. And the stars often stay in clusters. These clusters might be anywhere from maybe 10 to a couple hundred stars. Our sun actually was born in a cluster, but the cluster that our sun was in has broken apart. They've all separated from each other. But the cluster, you all know about star clusters, and you probably know of one in particular. The Seven Sisters or Pleiades. The Seven Sisters are Pleiades. It's a small little cluster, and it is very small in the sky in comparison to the size of the constellations. But when people see it, they know it's something, but they might not know exactly what it is. There's roughly 7 stars, 6 to 7 stars that you can count with the naked eye. So the Pleiades is an excellent example of what a cluster of stars looks like. Now it's also in essence, it's also one of the few clusters that can be seen with the naked eye. Most of the deep sky objects, you do need a telescope. You don't need a lot of magnification. Maybe anywhere from about 30 to 150 is usually more than adequate for most deep sky objects. Of course, there's always exceptions. For the Pleiades, or Seven Sisters, those are best viewed through binoculars because it is really a large object. Telescopes tend to magnify, so that means you will only maybe see a part of it when you're looking at the Pleiades through a telescope. But the binoculars, you get to see the entire Pleiades just hovering there, right before your eyes. It's really a pretty sight in binoculars. Now, again, there are many star clusters. Many are clusters of stars that you need a telescope to observe with. They're a lot smaller, they're a lot fainter, but some of them are very pretty. There's a few that that sort of tickle me with delight, if you want to use those words. I have favorites that I like to go back continuously when they're in the night sky. Okay, nebulae. Nebulae are basically giant gas clouds in the sky, and there's a few different types, but I'm going to concentrate on the big ones that actually create stars. They're the birthing place of stars. The one that I know everyone basically has heard of, but you might not have seen, is the Orion Nebula. Okay, so the Orion Nebula is a giant gas cloud, and when I say giant, when I say gas, we're talking about trillions of miles across. And when I say gas cloud, it's mostly hydrogen, maybe with a little bit of helium mixed in. But these giant gas clouds, these nebulae, yes, they can concentrate. That is, concentrations or condensations can occur within them, and stars are born out of those concentrations. Often they're born, a whole bunch of them are born in and around the same time to create a cluster of stars. Okay, galaxies. What about galaxies? There is one galaxy that you can actually see with your eyes. You need darker skies, and of course you can see it in binoculars. And everyone has heard of this galaxy, just whether or not you've actually seen it. Most of you have probably seen a picture, but that's the Andromeda Galaxy. Yes, the Andromeda Galaxy can actually be seen with your naked eye in a dark location. Now, it's not great with your naked eye, but it's possible to see it. With binoculars, which intensifies its light, you can see it even better. And then, of course, with telescopes, you can also observe it. The Andromeda Galaxy is physically in the sky. It does extend a great distance. So in a telescope, you're going to only be able to see pretty much the center part, which is the brightest. So again, most galaxies and most nebulae, which I didn't quite say before, they almost all of them require a telescope in dark skies. So deep sky objects basically need to be observed. One is when the moon is not out, or maybe when the moon is not bright. You can observe some maybe up to a quarter of a moon. But the moon basically needs to be absent from the sky, and you have to be away from city lights. So anything that whitewashes the sky basically whitewashes deep sky objects. So deep sky objects are, after I think someone learns the constellations and has observed the moon and the planets, it tends to be the list of things that someone tackles. And they're very rewarding. Every deep sky object is different, just like every individual is, and I think you will enjoy them, and I hope you spend some time trying to find them, seek them out, and just to enjoy the beauty that they give. So good luck. and take a look at some of the other parts. And again, I hope you go out, observe the wonder, the beauty of the universe, and have fun with it. Okay, bye. I wanted to talk about some of the limitations that we have when observing the night sky. The biggest limitation, which I think you can probably guess, is light pollution. For the most part, when we need a nice dark sky to observe, let's say, the Milky Way or some of the deep sky objects, that is galaxies, nebulae, and clusters of stars, we, if we live in a city, we have to travel outside of it. Light pollution has definitely put a crimp in astronomy, especially in the large cities. So in cities like Los Angeles, San Francisco, places like Chicago and Phoenix and New York City, in essence, you won't be able to observe any constellations. Maybe a few of the bright stars, but that's probably that's the best. That's the best you'll be able to do. Now the planets, the bright planets like Venus and Jupiter, they will be visible from from light polluted cities, and light pollution does not adversely affect observing them. So if you can locate between the buildings and everything else in large cities, by all means you'll be able to enjoy. By all means, observe the planets, and you'll be able to enjoy them just as if you were out in the country. Now, another limiting factor with observing is the moon. Yeah, and in some ways, the moon is a natural light polluter. When the moon is bright, and when I say bright, let's say if you take full moon about a week before and a week after that, so it's which is called from first quarter to third quarter. That's what I call basically a bright moon. If the moon is out during that time, it will be bright enough to whitewash the entire sky, making it difficult to observe the deep sky objects. Again, the planets, that won't be a problem. And in fact, when I say any of the planets, any of the naked eye planets, you can observe when the moon is bright. But I have had some success observing deep sky objects up to first quarter, which we'll call half of a moon. Beyond that, the brightness of the moon whitewashes the sky out, and it's difficult to see those fainter deep sky objects. Okay, turbulence. The atmosphere can often be turbulent, making many of the images in telescopes fuzzy or blurry. Blurry is, I guess, the best word. Deep sky objects, those galaxies, nebula, and star clusters, are not as affected by turbulence as much as the moon and the planets. So now most the worst. Well, when I'm saying the worst, the most, there's all along the horizon. Let's say a band maybe going up about 1/4 to maybe up to 1/3 the distance to the zenith. Maybe about 1/4 is better. That band all around the sky is turbulent, and if the planets are in that area, the images in telescopes are just very poor. The planets and the moon will look like it's bubbling under almost any magnification, and at higher magnifications you'll see the bubbling even more. Deep sky objects are affected in that range, but because they're different type of objects, you can observe them satisfactory. Not the best, but you can observe them satisfactory in that range. Now, when all objects get above, let's say, 1/4 to 1/3 from the horizon, they appear much sharper. And this is all objects, deep sky objects, but in particular the planets and the moon. Now there's a caveat to that. If the atmosphere in general where you are is turbulent that night, or part of, sometimes it's just at different times of the night, but sometimes you get nights that are just extremely turbulent. The observing the planets and the moon will just be a lost cause. The deep, like I said again, the deep sky objects might fare will fare a little bit better. So there are some nights that are just much better to observe than other nights because there just isn't as much turbulence. The difference between, let's say, a perfectly calm sky and one that has turbulence when you are observing the planets is being able to look at the planet and like Jupiter, for example, and just plainly seeing all of the details and intricacies, that it has to offer within its clouds. Where on a more turbulent night, a lot of that becomes blurry. And on more turbulent nights, if it's an extremely turbulent night and you want to observe the planets, you just need to hang it up. It's not worth observing. But on I would say a normal night, which will exhibit some turbulence, there are what are called moments of clarity. And moments of clarity are split seconds, maybe up to a couple of seconds of a clear window where you can look upon the surface of the moon or the planets and see the details in the way that we all like to. I would say on an average night, the moments of clarity may just be a split second or so, but they happen frequently. And so we just sort of in our minds accumulate all those little split seconds, to get quote a clear view. But on a steady night, the moments of clarity are usually much longer, and so the being able to observe the detail, like on Jupiter on the moon, is much more satisfying. So those are some of the limitations that we have. That we have observing the night sky. Everyone has to work around them. All the professional astronomers have to work around a bright moon. All the professional astronomers have to work around turbulence in the sky. So these are things that unfortunately are just part of the hobby. Okay, go out and hopefully you'll get a lot of good clear nights to enjoy the planets and the moon and everything else. Okay, bye.